Hello,
So
am I not
using
audible?
halogen.
Using halogen. Very good. Using halogen. Now, today we'll learn same. That is the third or C part, that is via alkene. And the second method of preparation from alkene is we will be using hydrogen halides. Okay, using hydrogen halide. What are hydrogen halide? Hydrogen halide are, for example, HF, HCl, HBr, HI. These are hydrogen halide. Now, please write with me. And alkenes are treated with and alkenes are treated with hydrogen halides. They form corresponding alkyl halides. They form corresponding alkyl halides. So a simple reaction that I will show you is if you have carbon double bond carbon, both of these carbons are attached with some groups, and I react with hydrogen halide HX, then what will happen? The groups that it has been attached earlier with, they will be as it is. There will be no change in them, but hydrogen will be added in one of the carbons and halogen will be added in other carbon. Okay, so write this general reaction. And after this, we will look at the mechanism. Now, all of you wrote the reaction, yes or no? Please tell me.
So 1 minute.
Okay. Mansi joined. Okay.
Done, sir.
Okay. Now, for the mechanism, please write. Let us suppose we have a reaction like this, okay, in which we have CH3, single bond, CH double bond, CH2, and we add H, let us say Br with it. And what will be the product? As you can see, in the double bonded carbon, we have two carbons, right? One carbon and two carbon. So what can happen here? Either the bromine will add on the first carbon and the hydrogen will add on the second carbon, right? Br in the first carbon and hydrogen on the second carbon. Or what can happen is that the hydrogen will add on the first carbon and the Br will add on the second carbon, right? So both of these possibilities are there. Hence, we will make both the products now, and then we will look at the mechanism, and then mechanism will help us to determine which will be major product and which will be minor product. So CH3, CH, Br, then again a CH3 here. So we earlier had CH2, so we added a hydrogen which made it CH3, and we will have CH3 single bond. Earlier we had only CH, so hydrogen will add in the second carbon, it will make CH2, and the third carbon will be CH2 as it is, and then the Br will be added in the third carbon. So these are the two products that can be formed, है ना? Yes or no? यहाँ तक सबको समझ में आ रहा है? The possibilities. Tell me yes or no.
Yes, sir.
Right. The
Yes,
possibilities
sir.
are two. The possibilities are two. Okay. Now, in the mechanism, let us write the first step. We have CH3, CH double bond, CH2. Now, this is an alkene. An alkene has pi bond, and this pi bond is what? There is a concentration of electron here, right? Now, if the electron are concentrated here, and we also know that pi bond are made how? You have this pi and this p orbitals. They will there will be overlapping with each other. and they will make a pi molecular orbital like this. So what happens? Pi is an electron source, or it is electron rich, right? Pi is electron rich. Plus we have HBr. Now in HBr, you can say that either you can say that it will be present as H plus and Br negative, or also you can show the polarity as a dipole moment, that the H will have delta positive charge and the Br will have delta negative charge due to the difference in electronegativity. And now what will happen? Whenever you are going to move electrons, you'll always start from the electron source, electron rich source towards electron poor. So electron rich is what? CH and CH2, and it is going to attack on hydrogen of HBr. Now there are two possibilities. Now, this pi bond will break, and this pi bond will get attached to this hydrogen, or it will get attached to this hydrogen. So what can happen? You can say that CH3 single bond CH, and this carbon gets the hydrogen, and the other carbon CH2. Now this CH2, it earlier had two bonds with carbon and then two hydrogen bonds. That means 4 bonds were there. Now it has only 3 bonds, and that is why it will get a positive charge. It has lost electron. The bonded electron has been lost. This is one of the product that you can get, and the other product that you can get, if the hydrogen gets attached on the third carbon, you will be getting CH3 CH, and this will get a positive charge followed by CH3. Now, do all of you understand why will these two products formed? Yes or no? Please tell me. Because the pi bond can break and the hydrogen can get attached on either the second carbon or the third carbon. And in both the products, we will get a byproduct, that is Br negative will be there. And the Br negative is still there. It is not reacting with any of it till now. Is this clear with the second one? Yes or no? Please tell me.
Yes, sir.
Okay. The second step is clear. Yes or no? Mansi, Kulsum, आप लोग की तो आवाज ही नहीं आती है. Tell me, is this clear? Yes or no? Okay, fine. Now you tell me which will be more stable, A or B? Which intermediate is more stable, A or B?
B.
B will be more stable. Very good, because it is 2 degree. Hai na? This is going to be 1 degree. This is going to be 2 degree, and you will write it is more stable. It's going to be more stable. Now, if it is more stable, then what will happen? It will be easily formed. And in the second step, we can say that in the second step, what is going to happen? CH3, CH positive, and then CH3. It will be attacked by the Br negative that we have already in the beaker. In our solution, we already have a Br negative that is coming from HBr. Now, this Br negative is what? Is our electron source, and it will attack on this carbon atom. And a negative charge, that means there is an extra electron there. They will add up to make a bond like this, CH3, CH, CH3, and Br. Okay, so this will be our major product. Okay, this will be our major product. That means the reaction here you can write, this will be major, and this will be minor product. Okay, all of you understood this session? No, please write this down. 2-step mechanism is there. Done all of you? Yes or no? Please tell me.
1 minute.
Okay.
Done, sir.
Okay. All right, next. Let's do some questions. Before that, write a point, Markovnikov's rule. So Markovnikov, he was doing many reactions on alkenes and hydrogen halides, and he saw that always what is happening, the Br is getting attached. That means the negative part. Br is the negative part of the reagent. It is attaching on that carbon atom, which is having lesser number of hydrogen, right? So in this, we have CH and CH2. So CH has less number of hydrogen atom, and he saw that it is getting attached on the more substituted carbon, or we can say the carbon which is having less number of hydrogen atoms. So Markovnikov, he said that let us make a rule. So he said, please write with me. When an unsymmetrical alkene reacts with unsymmetrical reagent, then the negative part of reagents attaches with that carbon, attaches with that doubly bonded carbon, with that doubly bonded carbon, which has lesser number of hydrogens. Okay, अच्छा इसी के साथ साथ प्लीज राइट एंटी मार्कोनिकॉव रूल. When unsymmetrical alkene reacts with HBr in the presence of peroxide. Peroxide is formula is ROOR. When unsymmetrical alkene reacts with HBr in the presence of peroxide, then the Br attaches to that carbon which has more number of hydrogens. Write these two rules. We already know what is Markovnikov's rule and why it is happening. Unsymmetrical alkene, that means unsymmetrical alkene means there will be different number of carbon atoms in either side of the double bond. That is how you will identify unsymmetrical alkene. Unsymmetrical reagent, that means you have HCl, right? So it will be what, delta positive, delta negative. If you have heterodiatomic molecule, heterodiatomic means you will have both these atoms are different. Okay, it is diatomic molecule. That means there are two atoms and both the atoms are different. HCl, HBr, HF, all of these are example for unsymmetrical reagent. Okay, and we have seen why it is happening. It is due to the stability of carbocation. It is due to the stability of carbocation. Please write this down. Let me know when you're done. So pi bond breaks, right? You have to also consider what are the bonds getting broken, what are the bonds getting formed. This is the first level of information that you can have in any organic chemical reaction, that which is the bond that is getting broken and which is the bond that is getting formed. So in addition of hydrogen halides on alkene, the pi bond gets broken, a new carbon halogen bond is formed, and a new carbon hydrogen bond is formed. And which carbon is going to get bromine and which carbon is going to get halogen and which carbon is going to get the hydrogen, it depends on the condition. If it is done without peroxide, then the negative part, any halogen, it will be attached on that carbon that is having lesser number of hydrogen. But the anti-Markovnikov rules, it is only for HBr. Okay, it only happens with HBr, not with HCl, HCl, anything. Write this down. Let me know when you're done. Done? Yes or no? Please tell me.
Yes, sir.
Okay, so we have two cases. You have to always remember this. Markovnikov and anti-Markovnikov, presence of peroxide and absence of peroxide. Please write a question. Okay. If you have my number, you can send it to me or you can send it to Learnivio. You have 5 minutes. So you can use this small flow chart. First of all, identify whether it is unsymmetrical alkene, yes or no. If it is not, then the halogen will attach on any of the two doubly bonded carbon atom. If it is unsymmetrical alkene, then you have to check whether there is peroxide, yes or no. If there is peroxide, then what you have to do, you have to draw the anti-Markovnikov product. That means the carbon will be at the halogen will be on that carbon which is having less number of more number of hydrogen. If it is Markovnikov, if there is no peroxide, then it is Markovnikov. Then you have to draw the Markovnikov product. Actually, please write this down. जल्दी कीजिए. You just have 3 more. You just have 2 more minutes. Okay, I have received answer from Akshay. Your answers are fine, Akshay, but आपने तो तुम जगह ही नहीं छोड़ा है. एग्जाम में ट्राई कीजिएगा, थोड़ा साफ साफ लिखिए, ठीक है?
ओके सर.
5 minutes is over. No one has sent me answers, except Akshay. Hamza, Hiba, Atif, Kulsum, Mansi, what happened? जितना हुआ उतना भेजिए जल्दी. I'm asking something. Hamza, हुआ? नहीं हुआ? Yes, Hamza. Hello. Am I audible? Atif, am I audible?
Yes, sir, you're audible.
Yes, sir.
Mansi and Kulsum, what happened?
Still trying, sir.
Trying? अच्छा ठीक है, रुक जाइए. Don't try. Leave your pen. All of you, please stop writing anything, whatever you are writing. Mansi, for the first one, tell me, is it unsymmetrical alkene or it is symmetrical alkene? What do you think? क्या लगता है आपको?
Symmetrical.
Symmetrical. That means the Br can be added on any of the carbons, yes or no?
Yes.
So whether you add the Br here on the second carbon, the name of the molecule will be same only. Okay, it will be always 2-bromobutane. 2-bromobutane. Whether you add it in the second carbon or the third carbon. Next one, tell me, Mansi, symmetrical or unsymmetrical? Please don't write anything.
Symmetrical.
Symmetrical or unsymmetrical? What, Mansi?
Unsymmetrical.
Unsymmetrical. Okay, fine. Now, is there a peroxide or no peroxide?
No.
No peroxide. So now tell me whether it will attach on the first carbon or the second carbon. Chlorine will attach on?
First carbon.
Bas, ho gaya. And hydrogen will attach on the second carbon. Please remember to remove this pi bond. Okay, the pi bond is going to break. Now for the C1, tell me whether it is symmetrical or unsymmetrical. Tell me, Mansi, symmetrical or unsymmetrical? Don't know?
No, sir.
नहीं, आवाज नहीं आ रही आपकी. कुलसुम बताइए, symmetrical unsymmetrical. Yes, Kulsum. What happened to Kulsum today? Okay, Kulsum लिखेंगी. Kulsum, can you please turn the mic on? Yes, Kulsum, can you please turn the mic on? If you are not able to turn the mic on, then rejoin. Okay, Kulsum. आप क्लिक कर रहे हैं माइक ऑन करने के लिए, नहीं काम कर रहा है तो फिर रीजॉइन कीजिए. Yes, Mansi, tell me for the C part, symmetrical or unsymmetrical? What do you think?
Not sure, sir. Not sure, sir.
Okay. We have double bond here. How many carbons are on the right side?
One.
How many carbons are on the left side? Is there one carbon on the left side or more?
More.
So it is unsymmetrical. Mansi, Kulsum, everyone understood this? Yes or no? Please tell me. There should be different number of carbon atoms on either side of the double bond. Okay? On either side of the double bond.
Okay.
Now, tell me, the I will attach on which carbon? The first carbon or the second carbon? किस पे attach करेंगे I को? Iodine will attach on the first carbon or second carbon? Tell me. Kulsum, answer in chat. Mansi, tell me.
First carbon.
Very good. And hydrogen will be attached. तो ये CH3 भी लिखिएगा, ठीक है? भूल मत जाइएगा इसको CH3 लिखिएगा, ये iodine हो जाएगा. Okay. D1, symmetrical alkene, unsymmetrical alkene. बताइए, ऐसे स्ट्रक्चर सिमेट्रिकल लग रहा है, अनसिमेट्रिकल लग रहा है? सिमेट्रिकल और अनसिमेट्रिकल, ये तो बताइए.
Unsymmetrical.
Okay. All of you agree, yes or no? Please tell me. It is unsymmetrical alkene.
Yes. Yes. Sir.
Okay. Now, peroxide or no peroxide? Peroxide is there. So the Br will attach on which carbon? First carbon or second carbon?
First one.
Second.
और अगर peroxide नहीं रहता तो कौन से कार्बन पे होता? मानसी, कुलसुम.
Second.
वाह. पढ़िए मार्कोनिकॉफ रूल, एंटी मार्कोनिकॉफ रूल्स पढ़िए, उसके बाद बताइए. How many hydrogens are there in the first carbon? Tell me. इस फर्स्ट कार्बन में हाउ मेनी हाइड्रोजन आर देयर मानसी? हाउ मेनी हाइड्रोजन आर देयर इन द फर्स्ट कार्बन, बताइए। हम्म,
1 1
यहाँ पे 1 है, 4 बॉन्ड तो ऐसे ही बन रहे हैं, हाइड्रोजन से 5 बॉन्ड बनाइएगा क्या?
हाइड्रोजन।
देखिए आप लोग, देखिए ये सारी चीजें जो है ना, बहुत छोटी छोटी चीजें हैं, इसी में फंसिएगा। बॉन्ड लाइन स्ट्रक्चर में जब भी नंबर ऑफ हाइड्रोजन बताना हो, ठीक है, 4 माइनस बॉन्ड्स। मानसी बताइए, ये जो फर्स्ट कार्बन है कितने बॉन्ड बना रहा है? हाउ मेनी बॉन्ड्स कैन यू सी?
4
तो कितने हाइड्रोजन हो जाएंगे बताइए?
none
0। सेकंड वाले में बताइए कितने बॉन्ड्स दिख रहे हैं आपको, रेड वाले में?
3
हाउ मेनी?
3
माइक ठीक से ऑन करके बताइए ना भाई, कुछ बज रहा है
3
पीछे आगे, ठीक है कोई बात नहीं, हाँ समझ में आ गया, 3। तो कितने हाइड्रोजन हो जाएंगे?
1
बताइए, वेयर शुड द वेयर शुड द ब्रोमीन अटैच? फर्स्ट कार्बन, सेकंड कार्बन?
second carbon.
समझ में आई बात?
Yes sir.
गलती होगी अब?
No.
पक्का?
Yes sir, I'll try.
ट्राई का क्या मतलब है? गलती हुई तो? हाँ मानसी, व्हाट विल हैपन देन? गलती हुई तो?
Then I'll try again.
यू विल ट्राई अगेन, वाह। आई विल स्कोल्ड यू, ठीक है, अगर बाद में गलती हुई तो। अग्रीड? डांट पड़ेगी आपको।
Yes sir.
हाँ। सिमेट्रिकल है अनसिमेट्रिकल है? टेल मी, व्हाट डू यू थिंक अबाउट द स्ट्रक्चर, द E1, सिमेट्रिकल और अनसिमेट्रिकल?
Symmetrical.
Symmetrical. That means we can attach the chlorine on any of the carbons, ठीक है? चलिए, done all of you, yes or no, please tell me.
Yes.
Okay. See, we have seen what happens in what we know what happens in the presence of peroxide, but we don't know why this is happening in the presence of peroxide. So all of you please write. किसी ने आंसर नहीं भेजा, कितनों का सही था बताइए तो जरा। टेल मी इफ योर आंसर वाज रॉन्ग, इफ एनी वन ऑफ देम वाज रॉन्ग, रेज योर हैंड। या फिर कि कोई, कौन सा नहीं कर पा रहे थे आप लोग? हमजा, कौन सा नहीं कर पा रहे थे आप? हमजा, सारे हो गए थे?
No sir, third one.
थर्ड वन। सिमेट्रिकल अनसिमेट्रिकल पहचानने में दिक्कत नहीं होना चाहिए, ठीक है? यू जस्ट ड्रॉ लाइन, लाइन ड्रॉ करने के बाद भी आपको पता चल जाएगा, पूरे मॉलिक्यूल ऐसे ड्रॉ कर लीजिए, यहाँ से ऐसे ड्रॉ कर लीजिए, यू विल गेट टू नो वेदर इज सिमेट्रिकल और अनसिमेट्रिकल, ठीक है? चलिए, राइट द मैकेनिज्म फॉर पेरोक्साइड। Rather you should write HBr in the presence of peroxide. This is the product, this is the major product we'll write. This is the minor product in the presence of peroxide. Right mechanism. ठीक है, मैकेनिज्म में देखिए सबसे पहले क्या होता है. नंबर 1, we have HBr. Okay, in the presence of peroxide, and sometimes you can see light also. Okay, in the presence of light, actually any free radical generating reagent. Okay, if you have free radical generator, that means helper is there, then what will happen? You will get the major product, which is having anti-Markovnikov product will be the major product. HBr in the presence of peroxide, peroxide is ROOR. Now what happens? First of all, let me erase this RHBr. The first step is this breaks. Peroxide, it will break into RO free radical and RO free radical. Okay. Then the next step, what is going to happen? The RO free radical, it will attack on the hydrogen of HBr, because hydrogen is delta positive and Br is delta negative, and it will make ROH. And the Br negative will be as it is. Sorry, not Br negative, rather there will be Br free radical, right? Hydrogen को attack किया यहाँ पे, and this Br gets one free radical electron. Now what is going to happen? You have CH3, CH double bond, CH2. Now what is going to attach here? What is going to attach here? Here we are going to attach the Br free radical. So now Br free radical can either attach on this carbon or it can attach on this carbon, breaking the double bond. Okay, by using the double bond, what can happen? It can attach on either of them. So let me write it like this. Let me make it green. Okay, and what can happen? These two electrons can take part in bond formation, or these two electrons can take part in bond formation. दोनों cases में क्या होगा? Please look here. If I take the red case and Br gets attached on the second carbon, then we will be getting CH3, CH, Br, CH2 free radical will be there. And if it attaches on the green carbon, then we will be getting CH3, CH free radical, and then there will be CH2Br. बताइए which is, now you have to look at the free radical. ठीक है, अब halogen के जरिए मत देखिएगा. You have to look at the free radical and tell me which will be more stable, A or B, the red one or the green one. अक्षय के अलावा बाकी लोग बताइए, A or B, which will be more stable? Look at the free radical and tell me which free radical will be more stable.
Sir, B.
B will be more stable because it is having free radicals. They are all, yes, Kulsum, correct. मानसी, आपको समझ में आया? Why B?
Yes, sir.
आतिफ, what about you? आपको तो आ रहा होगा. आतिफ.
Yes.
आयशा, what about you? अच्छा, आप आ गई आयशा. But Aisha is silent. ठीक है. So B is more stable. एक ही कहानी है पूरे ऑर्गेनिक केमिस्ट्री में, एक ही कहानी है. रिएक्टेंट इंटरमीडिएट. Reaction intermediate should be more stable. If more stable, then it is going to give you the major product. That means if it is more stable, oh, you are at office only. Okay, okay, fine. Acha, acha. Okay, fine, fine. It will be more stable. In the third step, what we'll do? CH3, CH free radical, CH2Br, and then there is hydrogen free radical, or you can say that HBr यहाँ पे होगा ना. What can happen now? This free radical can attack on the HBr also. This hydrogen will get one of this electron, and you will get CH3, CH2, CH2Br. ठीक है? So these are the three steps in which it is happening. Now the first step is what? Chain initiation. Second step is you have two steps in which we have chain propagation, and there is chain termination step. That is the last step. Okay, and that is why you get the major product, which is the anti-Markovnikov product. Also, we can call it anti-Markovnikov product. Okay. Now please write a note. Markovnikov's rule is also called Kharash effect, and peroxide effect. And peroxide effect. So actually, in Markovnikov's case, what was the case? He was doing alkene plus HBr in day and in night. So in day he was getting this type of product. ठीक है, alkene अगर मान लीजिए आपका इस तरह का है, and in night he was doing, then he was getting this product. He was utterly confused. Okay. So day and night. That means in the presence of light, if you do, or peroxide, then what is going to happen? Anti-Markovnikov's product will be there. Kharash, I think he was a colleague of Markovnikov or something, or he was a student of Markovnikov. Markovnikov, he did not understand about the free radical mechanism. Kharash, what he did, he just read the notes, lab notes hote na. So people who do science, they maintain lab notes. What is my product? What is not my product? So Kharash, he asked for lab notes of Markovnikov's, and then he gave his own Kharash effect. But it is still known as anti-Markovnikov's rule because the reaction, they were done by Markovnikov's, and the observation was, the finding was of Markovnikov. Markovnikov found that it is giving different product, but the observation was done by Kharash. And again, this is a legend. I don't have any particular source or very good source for it. I heard this in a chemistry podcast, and whoever was there, he also said that he has also just listened to it. There is no written account of this Markovnikov and Kharash effect. Okay, so रात और दिन का फर्क है. किसका फर्क है? रात और दिन का फर्क है. If you do it in the day, then you are going to get Kharash. If you do it in the night, you are going to get Markovnikov. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now, right, next one. Right, next. So in alkenes, we have done two. First one is halogenation, simple halogenation. Then we did what? Then we did addition of halogen. Then we did addition of hydrogen halide. Addition of hydrogen halide. Now, right, Sandmeyer's reaction. This is completely different. That's right. This is third part, Sandmeyer's. Reaction. Okay. Now, Sandmeyer reaction is important because it is what? It is a name reaction. So whenever, I think this is the first name reaction that you are coming across. So in name reaction, what I used to do, wherever you have name reaction, you just write it like this. CBSC. Because in board examination, these name reactions are very important, or you could write it name reaction. Okay. And the way to remember, there will be many name reactions. Okay, there will be many name reaction. Now in this chapter you have less name reaction, but as you move on, there will be many name reactions. So the only way of learning the name reaction is that you learn it via chapter. That means haloalkane, haloarene, we have this many name reactions. Okay, then alcohol, phenols, and ether, we have, these are the name reactions for alcohol, phenol, and ether. Then we move on to aldehyde, ketones, and carboxylic acid. Then we have these many name reactions. For amines, we have these many name reactions. Okay, so once you are done, then how will you classify them? You will classify them according to the chapter. Okay, so this is the first name reaction that you are going to learn, Sandmeyer's reaction. Is this clear? Yes or no? How to learn it? Yes or no? Please tell me, all of you.
Yes, sir.
Yes,
Yes, sir.
sir.
Okay, fine. So in Sandmeyer's reaction, first of all, what we do, you can write the Sandmeyer reaction in two types of case. First of all, write what happens in Sandmeyer reaction. It is used to produce aryl halides from aryl disonium salt. From aryl disonium salt. Okay. Now, what is the Sandmeyer reaction? Please write. When benzene disonium salt reacts with cuprous chloride or cuprous bromide then it forms chlorobenzene and bromobenzene respectively. What is benzene diazonium salt? We have benzene diazonium salt. That means we have N2. There is a positive charge here. And there is Cl negative here. As you can see, positive and negative charges are there, similar to Na plus and Cl negative, right? So whenever we have positive negative charges, we say them, they are salts. They are salts. Benzene disonium salt reacts with cuprous Cu2Cl2, cuprous chloride. It is going to give me chlorobenzene. As simple as that. Is this clear? Yes or no? Please tell me. Sandmeyer reaction. Again, if you have.
Second is roller.
Oh, wait a second. More up. Or is this fine?
Some more.
More up.
The first. Done, sir.
Done all of you? Yes or no? Please tell me.
Yes.
Okay. Now write formation of disonium salt. How will you form disonium salt? So first of all, we take aniline. Aniline is a benzene ring in which NH2 is attached. And we react this with NaNO2 and HCl. And this gives me the benzene disonium salt. Okay. So they will write, they will give you a question, what reagent will you use for the following conversion? They will give you aniline, and they will ask you, I have to make chlorobenzene. So we'll say the first reagent that I will add is NaNO2 in the presence of HCl or HBr or HX, anything. Okay. So let me, my teacher in my graduate school, he said that you should write the reagent first and then draw the arrow. And I always make the mistake of drawing the arrow first. So the first reagent should be NaNO2 plus HCl. Second reagent should be Cu2Cl2. Right. So these are the two reagents we are using for the following conversions. Chaliye, please write this down. Let me know when you're done. Is everyone done? Yes or no? Please tell me.
No, sir. Only.
Okay, please write this fast.
So can you please scroll a bit up? Yeah, okay.
कितना आप?
Done, sir.
Done all of you? Yes or no? Please tell me. Done everyone?
Yes.
Right, the last one. Method of preparation will finish here. Halogen exchange methods. Again, a new name reaction. The first halogen exchange method is Finkelstein reaction. Okay, in halogen exchange method, what happens? We take an alkyl halide and then we react it with something to get another alkyl halide. Okay, so please write when chloro or bromo alkenes are treated with sodium iodide in the presence of dry acetone, it leads to formation of iodoalkene. It leads to formation of iodoalkene. That means if you have CH3, CH2, Cl, or you have CH3, CH2, Br, and what you do? You react this with sodium iodide, and you react this with sodium iodide in the presence of dry acetone. Okay, in the presence of acetone. For both the cases, you will get CH3, CH2, I. ठीक है, CH3, CH2I. Done? Yes or no? Please tell me.
No, sir.
जल्दी लिखिए.
Done, sir.
All of you done? Is there anyone who's still writing? Next लिखिए Schwarz reaction. Is there anyone who is still writing? Yes or no? Please tell me. Is there anybody? अरे हाँ या ना कुछ तो बोलिए, क्या हो गया?
Done, sir.
Done ना? Okay, fine. Right, Schwarz reaction. When alkyl, oops, no, alkyl chlorides or bromides are treated with metallic fluorides, they form alkyl fluorides. Simple reaction is if you have CH3, CH2, X, here X is equal to chlorine or bromine only. Okay, chlorine or bromine only. Okay, in the presence of metallic fluoride. I have to take an arrow. Yeah, metallic fluoride, they form what? CH3, CH2, fluorine. What are the metallic fluorides that we can use? There are many metallic fluorides that you can use. You can use HEF, or you can use Hg2F2, or you can use antimony fluoride also. Okay, so these are things that you can get. So what's the action? Done, everyone? Yes or no? Please tell me.
10 minutes, sir.
Oh my God, I'm sorry. What happened now?
Sir, can you please read the metallic fluorides?
Metallic fluorides, what do I have to do?
Can you please read them?
AgF, Hg2F2, SbF3. Last one is SbF3. Oh my God, my handwriting is so bad. Done, all of you? Yes or no? Please tell me.
Yes, sir.
Done, sir.
Done. Okay. Now, your work from now is what? What you have to do now? You have to see. Now, what you need to do is write like this: alkene. What are the method of preparation that we have learned? We started with alcohols. Okay. Then you will draw it like this. Okay. And then an arrow like this, and you are going to get haloalkane. Okay. And you will write all the reagents here. And then what you will write? You will write a note like this: SOCl2 important. Now you will already know why it is important. Then next what you will do? Alkane. Okay. Haloalkane in the presence of X2 plus H nu. then you will write mixture. जो भी आपको important लगे. You understand why I'm saying mixture? Yes or no? Please tell me. In
Yes,
this reaction, we get mixture of product. That is why it is it is not preferred, right? Alkene. Then after that, we did alkene. Okay. So in alkene, what you will do? You did X2. है ना? Then that what I will be getting? Will write. I will get dihalo. ऐसे जो main important points है ना, what you have to do? You have to write them. You have to write them. Then we also did alkene in the presence of halo acids HX. यहाँ पे ऐसे आप लिख दीजिएगा मार्को. ठीक है, तो याद आ जाएगा कि मार्कोनिकॉफ एंटी मार्कोनिकॉफ. सिमिलरली व्हाट यू विल डू alkene HBr plus light or peroxide. Then you will write anti marco AM. ठीक है. Then you will write electrophilic aromatics. यहाँ पे बेंजीन लिखिएगा ऐसे. You will write the reagents and you will write it is electrophilic aromatic substitution. ठीक है. Then we will write halogen exchange. उसमें क्या आएगा? Finkelstein and Schwarz. ठीक है, तो इस तरह से you will have one हाफ नोटबुक जिसमें आप सारे के सारे मेथड ऑफ प्रिपरेशन और उसके इंपॉर्टेंट पॉइंट्स जो है, अल्कोहल में क्या इंपॉर्टेंट है, अल्केन में क्या इंपॉर्टेंट है, अल्कीन में क्या इंपॉर्टेंट है, मार्कोनिकॉफ में क्या इंपॉर्टेंट है, और यहाँ पे बस आपका हैलो अल्कीन लिखा रहना चाहिए. इज दैट क्लियर? यस और नो? प्लीज टेल मी. नो स्पेसिफिक्स. अल्कोहल कौन सा ले रहे नहीं पता, ठीक है, बट एटलीस्ट यू शुड हैव अ ग्रेटर आइडिया, ग्रैंड आइडिया एक होना चाहिए कि अल्कोहल से हम क्या रिएजेंट यूज करें तो हमको हैलो अल्कीन मिले. हम फिनक्लिस्टीन में रिएक्शन में क्या करते हैं तो हमारे पास जो रिएक्टेंट है वो कौन सा होना चाहिए. So you should see, or you should have all the reactants whatever you are using in order to prepare the haloalkane in one line here. Finclustine नहीं लिखेगा यहाँ पे. You will write Cl और Br. यहाँ पे भी आपके पास Cl या Br होना चाहिए, है ना, दोनों में. And what is the haloalkane that we are getting? You will get fluoride and you will get here iodide. ठीक है, इस तरह से लिखिएगा आपको reagent के. Do all of you understand what you have to do? Yes or no? Please tell me now. सबको समझ में आया?
Yes, sir. Yes.
Yes. मानसी, कुलसुम, आयशा, what you have to do now? Tell me. समझ में आया या नहीं आया? ठीक है, अब देखिए यहाँ पे, अब देखिए अगर आपसे कोई बोले हाउ विल यू प्रिपेयर CH3CH2 OH से, you have to prepare what? CH3CH2 let us say fluorine. तो F को यूज करके, यानी कि you don't have any reagent in which you can make fluorine. So what you will do? You will start, first reagent will be SOCl2. second reagent आप क्या यूज कर लीजिएगा आप? Let us say AgF, है ना. पहला रिएक्शन अल्कोहल के साथ एंड देन द नेक्स्ट रिएक्शन इज स्वार्ट्ज रिएक्शन. समझ में आया? तो यहां से भी आपके पास कन्वर्जन्स हो जाएंगे, है ना. सो यू कैन सी, ओके, अल्कोहल से स्टार्ट किया हमने, पाथ आपको नजर आना चाहिए, मैप है, बिल्कुल मैप. हेलो अल्केन से यहां पहुंच गए हम. ठीक है, दिस इज गोइंग टू हेल्प यू अ लॉट. ओनली दिस इज गोइंग टू हेल्प यू इन कन्वर्जन्स. कन्वर्जन्स में आपको ग्रैंड आइडिया होना चाहिए कि व्हाट आर द थिंग्स दैट आई कैन यूज. सबको क्लियर हुई ये बात? यस और नो? प्लीज टेल मी.
Yes. Yes, sir.
ओके, ओके, फाइन. अब एक काम करना है आप लोगों को. चलिए, fill this form. All of you got the form? Yes or no? Tell me.
Yes, sir.
And please fill that form. Akshay is done. Anyone else? हो गया तो raise your hand when you're done. Raise your hand when you're done with the form. Kulsum is also done. Okay. Okay. Atif is done. Hamza is done. Aisha, Hiba, Mansi. Mansi हुआ नहीं हुआ? Yes, Mansi.
Sir, 1 minute.
Okay, okay, okay. जल्दी कीजिए भाई. कितने सवाल है? 1 2 3 4 5. यस नो करना है बिल्कुल. चलिए. Hiba, are you right? Are you giving the answers, or should I just assume that you have same answers as of Hamza? Should I assume that you have same answers as of Hamza? Okay, I think she is giving. Okay. Okay, I've got Mansi's. Hiba का नहीं आया है. Hiba, can you please answer me what happened, Hiba? चलिए. Write these questions. You have 30 minutes starting from now. एक चीज तो नहीं भूलिएगा आप लोग, राइट द नेम ऑन टॉप ऑफ
So the first question, for example, do we have to draw the structure or write the name or both?
नो यू जस्ट हैव टू गिव एन एग्जांपल एज यू लाइक इट। स्ट्रक्चर बना दीजिए, नाम लिख दीजिए, कुछ भी चलेगा।
Okay, sir.
2 मार्क्स होनी ना, तो हाफ मार्क्स का है, तो उसके अकॉर्डिंगली आप लोग जज कीजिए क्या करना है नहीं करना है, ठीक है। टॉप ऑफ द ऑन टॉप ऑफ द फर्स्ट पेज। ठीक है, 3 स्टेप्स। I'm just stepping out of the room for a while. If you have any doubts, just wait for a while. I will be back. Okay. If you have any doubt, then you can ask me now. Akshay, you don't need to draw the bond line structure. You don't need to show me the bond line structure. You can draw whatever structure is you can draw. Open, like means expanded one, or even if you want to draw the Lewis dot structure with the dots and all, you can draw it. Okay, and bond line also you can draw. Okay, it should be right. That's it. Any of the representations is fine. Atif, I have got your answer. Okay, if you want to leave, you can leave now. Or if there is anything that you want to discuss, you can let me know now.
No, sir. No.
Nothing? Okay, fine. Thank you. Take care. Do practice, huh? I will be posting assignments, okay? Please practice. Okay, Atif?
Yes, sir.
Okay, thank you. Bye-bye. Take care.
Thank you, sir.
Thank you. You guys have just 10 more minutes. Also, please let me know when you are done and you have sent the answers to Learnivio or me. If you have sent the answers, then you can leave, okay? Actually, a PDF will be helpful for me for checking now, as सब लोग
Okay,
photo
sir.
भेजेंगे तो right? You have time, so you can send the PDF. Sure. You guys have 4 more minutes. Yes, Kusum. So make a PDF and send it to Learnivio. So you have sent it to Learnivio, Kusum? Yes, Kusum, you have sent it to Learnivio. No. Okay, fine. If you have no doubts regarding today's class, then you can leave. Okay, we'll meet on next. Achha, I may not be having class on next Saturday, by the way. I forgot to tell you. I have to take my sister to Aligarh for test, and I may not take the class. Okay, I'm just thinking about it, what to do. Okay, fine, guys. Hello. Thank you, Kulsum. Bye bye. Take care. And also practice. I will post the assignment. Okay, you will get the assignments. Thank you.